Welcome to Grade 10 Applied Math. We are in Unit 2, Chapter 5, and Lesson 2 is Solving Linear Systems Using Substitution. By the end of today's period, you'll be able to use the method of substitution to identify the exact solution of a linear system. If we recall last lesson, a linear system is when two or more lines, linear relations, interact. So they could be crossing, they could be parallel. They sometimes even are the exact same line, but we don't know it by the equation. So where we left off last lesson was taking two lines and graphing them and then seeing where they might meet. So it's much easier when the y is already isolated, because then we know our slope and our y-intercept. So we could actually graph this one right now. We're going to call this line 1. And call the first one line, line 1 and line 2. Makes more sense if they're in order. Now, let's go ahead and graph line 2 since it's already ready to do that. So if we do our y-intercept at -2, and we go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4, we're here. Now, you notice we're off the grid. That's not great. So a -3 over 4, we could also say is like positive over -4. And what would that do? We'd go up 3, 1, 2, 3, and then -4, 1, 2, 3, 4. And that's where we go. So I'd take a ruler and graph that line. I already had it kind of ready already, but there we go. Okay, and then we can start with the second one, or first one. The thing we want to do is isolate the y. So let's work on that. X minus 2y minus 4 equals 0. Notice that the y is already negative. In those cases, I like to move them over because it automatically changes the y to a positive. And that's what one of our goals are. Now, we need to get rid of the 2 here, and everything we've talked about prior means to divide that 2 by each term. And that should reduce us to y equals, this reduces to 2, and don't forget your negative, and there's a 1 here, so we can have 1 half x. So how will we plot this? Well, our b is -2, so it's the same place as this one, and our slope is 1 over 2. So up 1 over 2, up 1 over 2. And then we can graph that line. And I had it already ready to go. So then we say, well, where's our y-intercept? It's actually pretty easy because both the y-intercept slopes, where's our point of intersection is going to happen at both y-intercepts. So our POI is 0 because x is at 0 and -2. All right, so this is a recap of last lesson. It's important to know why we're doing this. So here is the visual. We have two lines, and we want to find out where they cross. Today's lesson, we're not going to look at the visual crossing of the line. We're just going to theoretically figure out using equations. So this would be called today an algebraic method for solving the linear system, and it will give you the exact solution. Sometimes in these cases, what if you had your lines crossed somewhere like in between? Just a what if scenario. That'd be really hard to judge. You'd be guessing, right? You'd say, oh, I think it's, 1 half, 1.5, and 3.6 or something like that. But it'd be a guess. The way to get the most accurate is to do it algebraically. Okay, so the exact solution. Steps to solving linear systems by method of substitution. Well, you can rearrange the equation to form y equals or x equals. Either one, as you're isolating one of them together if necessary. substitute one side of the equation you rearrange into that variable of the equation. Solve for the other variable. Substitute the value of the variable to determine into one of the original equations, and then solve the equation for the remaining variable, and then we check it, and then write a final statement. So these are quite lengthy, some of these, and so we'll start an example on the next page. Example 1. Solve and check. Number 1, y equals x plus 4, and 2 is y equals 2. Now this example is going to be substitution by comparison. And what we mean by that is we're going to compare the y1 equal to the y2. Okay, so we say let y1 equal y2. Well, then you ask yourself, well, what is y1 equal to? Y1 is equal to this whole thing, and y2 is equal to this whole thing. So here's the substitution part, into 2. All right, well, if this is y1 and this is y2, this whole side is equal to this. So we are basically saying x plus 4 is y1, and y2 is 2x minus 2. Now, I've used the brackets because it shows substitution, but when we look at that, there's nothing to distribute in front, so we just drop the brackets. And basically we said, if the left and the right side are equal, then the left and the left side are equal, then the right and the right must be equal. Again, why does this work? Well, we're looking for when the y is the same. When the y is equal. Because that's going to be where they share a point, right? If you look back here, the y's share a point. They're both -2 in both scenarios. And that's what we're looking for. So we're saying, well, let's test where the y's are equal. So that's why we're doing that. Where is the y1 equal to the y2? Because then you know that's where they're crossing there. So now that we have done this, the beauty is we don't have any y values. You can't solve an equation if you have two unknowns, an x and a y. You can only solve an equation when you're down to um, um, the same values, the same terms, so we can collect like terms. All right, so here we go. I recognize that the 2 is larger than the 1x, so I'm going to bring this over here, and then I'm going to bring, well, let's see what happens after that. So I leave that here. I have 2x minus x minus 2. Well, I don't want this 2 over here anymore, so I'm going to bring that over. We're going to have now 4 plus 2 equals, well, here we can say 2 minus 1 is 1x. We have 6 equals x. All right, so now we have isolated one of the terms. So now if we follow back to our steps, okay, we have done this now. We've done this. We've solved for it. Now we must solve the other variable. So now we substitute the variable into one of the equations. So 1. It doesn't matter which. I usually, if you have a preference of one being easier than the other, just glancing at these two, equation 1 looks a little bit easier because look, it's y equals x plus 4. There's nothing to do with the x. So we are going to substitute x equals 6 into number 1. Again, you can use either one, but number 1 to me looks like an easier equation. So you might have one that has fractions or large numbers and versus small numbers. And you might want to avoid the fractions or avoid large numbers. In this case, they're both pretty simple, but we're still picking the easier one. Y equals x plus 4. Y equals our substitution plus 4. So there's our substitution, 6. So what is 6 plus 4? That's easy. The other reason why we use this method is sometimes normally graphing it would fall off the grid, these nice little 10 by 10 grids we have. So we might want to use solving by substitution because it will get the exact answer. So therefore, the point of intersection is x6, y10. So we need to check this. Well, just to try it out, why don't we check the other one? Check with equation 2. Y equals 2x minus 2. And if we substitute the 10 in, we have 10 on this side. And 2 times 6 minus 2, we have 10. Okay, 12 minus 2. And now we have 10 equals 10. So, therefore, we proved it. Left side equals right side. Therefore, the solution to the linear system is 6, 10. Okay, let's move on to our next example. You can see that it gets a little more complicated because we're not always given an easy y equals mx plus b format. So, but other things give us clues on how we can handle it. So here's, always label your equations 1 and 2 or a and b, whatever you choose. And what we're looking for is there already one that's isolated? Is one already isolated? And it doesn't have to be the y all the time. Is the x or y already isolated? Well, we see x already isolated, so that's perfect. So we can make a package with this. So here is our bracket. X is equal to this. So whatever x is equal to can go right into that x. So what we say is we say sub 2 into 1. So we're going to sub 2 into 1. So we're going to take the x of whatever x is worth into there. So we make a 2 times a big bracket. Again, this is why we needed to know distributive property fairly well from the past. And so we put in our right side of number 2 and we distribute. So 2 times 4 is 8y. 2 times 1 is 2. Okay, nothing. So we just now broken down this bracket and we are remaining with the 3y equals 12. So see what this has done? From our original number 2, we've gotten rid of the x. We can't ever solve these if we have an x and a y term. They can't combine. So here we've gotten rid of the x, and now we have just like terms. Just like we did when we were collecting like terms, we want to collect the y's. So that means I want to move the 2 over and get it out of the way. So 8y minus 3y equals 12 minus 2. Okay, so 8 minus 3 is 5y, and 12 minus 2 is 10. All right, so at that point, we'd have a multiplication here, so we need to divide both sides by 5. And we have y equals 2. All right, halfway there. So once we have one, we need to substitute it into the other. All right, sub y equals 2 into which one? Well, you have to decide here. So, well, we're looking for x, right? We're trying to solve for x. And look, number 2 already has x isolated. So the work is done for you already. All you need to do is substitute it into here. So we want to substitute it into 2. Okay, so that is x equals 4y plus 1. X equals 4y. There's our bracket to substitute into. And 2, y was 2. All right, so x equals 8 plus 1 is 9. Okay, so therefore, the possible solution, I'm going to say possible because we're going to check it, is 9 and 2. 9 being the x, 2 being the y. So, do we check it? Well, we could check that. And which one looks easier? You pick sort of, well, let's just use number 1 just because it's definitely not the easier one. But let's say we were going to do left side and right side. And so we had before 2x minus 3y equal 12. So just to challenge ourselves a little bit and see how this could work. It doesn't really mean you have to always pick the easiest. Let's almost prove that you could pick a more difficult idea. Okay, so what was this then? 6, that's going to be 6. And so 18 minus 6 is 12. And our left side is equal to our right side. So now we've proven, therefore, the POI is 9, 2. Or the POI or the solution is. So we proved it. Very good. Here's our final example. And they don't make it easy for us this time. So we have some choices here. We could make both of them into y equals, or we could find an easy way to put one into the other. Let me do, yeah, let's try and this way. Okay, so we're going to call this 1. This is 2. I'm going to isolate both into y equals. All right, so x minus 2 equals 9. And now, of course, I want to get y by itself. So I have 2y, a negative. I don't really love that as a negative, but it will all work out. And then divide both sides by -2. All terms by -2. And so we get y equals, it becomes a positive now, 1/2, because there's a 1 here. 1/2 x, and now the negative and a positive is negative, and 4.5. So you can do a decimal. Well, actually, there's a reason why I want to show you this one, and I don't want to put a decimal there, although you can. So let's leave it as 9/2. Okay, so not great because we have fractions here, so not ideal, but we've called that 1. Okay, let's go with number 2 here. Pick some different colors so we don't get confused. Okay, number 2, 3x minus y equals 17. And maybe this time we will move the 3 over there. Yeah, sure. And again, I just want to show you different scenarios, Not always the quickest and easiest way, because that's not how it works. Sometimes you end up trying one way, and it doesn't always work the easiest way, and then I don't want you guys getting stuck. So better to show you, like, what if we come up with a negative? How am I going to handle that? What if I don't isolate the easiest part? So this becomes our y equals, again, a positive 3x and a negative 17. So now we have a y1 and a y2. So let y1 equal y2, and so that would be this bracket and this together. So let's put y1 into here. So 1/2 x minus negative 9 over 2 equals, I'll bring this in, 3x minus 17. So I want you to think about this. We could handle this with the fractions, but let's say you didn't want to do any fractions, and I'm just showing you another tool that if you're ever stuck with fractions, okay, I want you to scale it by the fraction. So scale by times 2. So what do I mean by that? We're going to get rid of those fractions by scaling everything up by a scale of 2. So what would that look like? So what was in all those? 1/2 x minus 9 over 2 and 3x and negative 17. I was careful to include the negatives in the brackets because it's a little easier. Okay, so let's look what happens here. The 2's cancel out the 2's, and that's why we did it. That's the whole reason. And so now we're left with the 1x minus 9 equals. Now here's a big change. This is where some change happens. 2 times 3 is 6x. 2 times 17 is 34, put a negative 34. And there we go. Now we have no fractions to deal with. So, and again, imagine a more complicated question than 2's. A fraction of 2 is not that hard. To deal with halves wouldn't be too more difficult. But let's say you had awkward numbers, like really strange denominators. This could be a simple way for you to do this. Now recognize that 6 is larger. We still have to solve for x here. So now we have only x terms, which is perfect. We want to get the x by itself. So let's move some stuff around. The negative 9 is there. When the 34 comes over, it becomes a positive 34. The 6 is already waiting, and when the x comes over, it's a negative 1x. Okay, so 9 minus 24, negative 9 plus 24 is 25. And we have 5x. We're going to divide both sides by 5. And that will give us x equals 5. So a lot of work just to get this one solution. All right, so now we need some space here. We're going to substitute sub x equals 5 into, well, choose which one looks easier. Is the y isolated already somewhere? Not really. Maybe the first one's easier? I'm not really sure. There's no great advantage to either one. But let's say we substitute it into 1. So 1 was, it goes back, and there's a good point here, is it goes back to the original of the start of the question. So x becomes 5 minus, maybe we have our bracket there so we can see it, 9. Okay, the 5 of course has to join the 9, so negative 2y equals 9 minus 5, negative 2y equals 4, and divide both sides by 2. So we're going to get y equals negative 2. So That's how those go. So therefore, we won't bother checking this one, but I think we're right. Therefore, the POI is 5 negative 2. Okay, so that's the lesson. And a very important skill, solving by substitution. Make sure you do plenty of practice with your homework. Okay, and now that we've done solving by substitution, we are going to try a couple word problems and put these into real life scenarios. So in the first example, we have a 16th birthday. And you know, when you need to book a party place or book a hall, often they will charge some money in advance and then you pay per guest. And that's the situation here. So Megan's 16th birthday, her parents are planning a party. They are considering Tony's Pizza and Hamburger Joey's, these two fictional restaurants. Tony's Pizzeria charges 150 to book the party room and $12 per guest. Now, anytime we see per, that reminds us of a slope. And if we know we're paying $150 to book it, that's an initial fee, which we call the B. Okay, so now that we kind of can dissect that, we go through and go. Hamburger Joey's charges $180 for the party room and $10 per guest. So a B of 180 and an M of 10. Okay, so that will help us by dissecting the question. It will help us with our part A. Part A says, write a system of linear equations. That just means come up with the two equations. So in example 1, we call maybe Tony's. We can call number 1. And we call Joey's hamburger place number 2. So for number 1, we are going to first of all, let X represent the guests. Let Y be the total cost. So if we said Y equals, okay, 150 to start plus $12 per guest, and that would be a linear equation. We get a system of linear equations when we have two of them. I'm going to call that y1, little y1, and a y2. Okay, so in the second one, in the hamburger joint, we get 180 plus 10x. And now we've made a system of equations. I know this confuses a lot of students, this wording of system of equations. All that means is come up with your two equations. Okay, how many guests? Now, B says, how many guests must attend for the charges to be the same? So when do both restaurants make the cost the same, right? At first, you'd be paying more for Joey's, but less per kid. Here, you'd be paying less for Tony's, but more per student per guest. So at some point, they meet and they crisscross, right? One would be coming up like this, one would be coming like this. At some point, they're going to meet. Anyway, so how do we figure that out? Well, we do our substitution. The nice thing is both have their y's isolated. So we are going to look for let y1 equal y2. Of course, y1 is this. y2 is this. Just that part, the right side of both. So we have 150 plus 12x equals 180 plus 10x. And again, we've gotten rid of the y's, so now we're just collecting like terms with the x. The 12 is larger, so I'm going to bring the 10 over to the 12. So I want to have a positive value for the x. And then we need to isolate the other numbers. So on this side I have 12x minus 10x equals 180 was already there, minus 150. Again, the sign changes when we move across the equal sign. So 12 minus 10, that gives us 2x. 180 minus 150 is 30. Divide both sides by 2. We get x equals 15. So, therefore, it will take 15 guests to break for the two costs to be the same. So at 15 guests, the restaurants will cost the same. Now, it begs a question comes, the next question would be, well, how much is that cost? This question doesn't ask that, but often you'll see that as the next thing. If we wanted to do that quickly, let's say there was a part C to this, I would just substitute that into whichever one looked nicer and easier. So let's say it was 1. Okay, so remember y was equal to 150 plus 12x. So y equals 150 plus 12 times 15. So y equals 150 plus 12 times 15, do it quickly, is 180, plus the 150 is 330. So both places would cost 330 at 15 guests. So it didn't ask for that, but I like to always solve things completely. Okay, moving on to the next word problem. Here it's a student council is running a school fun fair. They're trying to make money. Well, often when we run something like that, we might have to rent something. Well, with renting comes a cost. So here it tells us the cost is 120 plus $1 per serving. So, you know, the bag, the amount of kernels you're putting into the popcorn machine, or cotton candy machine, sorry, right? They're all broken down into servings. So on this side, we have a cost side. And on this side, the student council plans to sell cotton candy for 12. We have like an earnings side. Earnings. So the two are working against each other, the cost and the earnings. And now they've given us some different than we're used to using y equals mx plus b. But perhaps in this case, we're going to use c equals m being our slope. And they're telling us c is the cost and n is the number of people you serve. And the b can stay the b. Okay, so let's read through this. Can we come up with an equation to show the cost of operating? Okay, so it was the cost of, so C, it costs 120 to rent the machine. That's our B. There's our B, and there's our M. And plus 1, N for number of people we have. Okay, reading the next one, write the equation for the revenue. Revenue, I said earnings, so revenue. We're still going to use C because C is what we're trying to compare. And we'll see that we sell it, we're trying to make a profit, so we sell it for more than $1. We sell it for $2.50, and eventually, hopefully, we make up enough money to get back our 120. So our cost is $2.50 per person we serve, and there's no one's giving us a donation, so there's no B. So there's no B. All right. Now we can call this 1 and this 2, just so it's like everything else we've done with the systems of equations. So we've now made a system, a linear system. So now we have to solve it. How many people must buy cotton candy to break even? Okay, so let C1 equal C2. And so we have this stuff, oh, this stuff coming down here, this side coming down here. We don't have to put the 0. So 120 plus 1n equals 2.5n. Bring this n over and have 120 equals 250 n minus 1n. 120 equals 1.5n. We're just going to break this down, divide both sides. Sorry if the yellow doesn't show up all that well, but n equals 80. 80. So what does that mean? That means, therefore, 80 people must buy popcorn to break even. So that means, now these are called break-even problems. You're going to see these a lot over your time. Break-even problems. When does a company break even with their costs and then finally make that money back? I also like to say anything more than 80 you make money, you earn. So if student council wants to just break even, that's usually not the case. They're usually trying to do fundraising. They break even at 80, but if they sell 100 or 200 bags of cotton candy, then they can make a good fundraiser. So there's 2 examples of word problems from our substitution lesson. All right, thank you for watching.